chemical formula for PVC is C2H3ClN. The C and gray circles represent carbon. The H and white circles represent hydrogen. The Cl and green circles represent chlorine. The N represents a variable. In this chemical formula, N represents the amount of times this formula is bonded to itself in order to produce the item. PVC was actually developed twice. The first time it was discovered was in 1838 by French physicist and chemist Henri Victor Regnault. The second time was in 1872 by German chemist Eugene Beaumont. Both of the times that it was discovered, the polymer appeared to look like a white solid, like flour, after being exposed to sunlight. The first time somebody actually got a result and made a product was in 1926 by an industrial scientist, Waldo Semin. He was hired by the American company B.F. Goodrich. Their goal was to develop a synthetic replacement for the increasingly costly natural rubber. Sales began to increase with a very quick product range and during the World War II because it was used to insulate wiring on military ships and replace the traditional material. The top left picture is a vinyl-based latex that was used on inflatable structures and fabric coating. Some physical characteristics of PVC is that it can come in many different colors. It starts to decompose when the temperature reaches 140 degrees Celsius, with melting temperature starting around 160 degrees Celsius, which is very high for plastics. Some chemical properties is that PVC is chemically resistant to acids, salts, bases, fats, and alcohols. It is also resistant to some solvents. The intermolecular force in PVC is dipole-dipole. There are so many of them that pure PVC is a hard, brittle solid. Some electrical properties is that PVC is a polymer with good insulation properties, but because of its higher polar nature, the electrical insulating property is inferior to nonpolar polymers, such as polyethylene and polypropylene. Some properties that PVC has is that the synthetic plastic polymer is resistant to light, chemicals, and corrosion. The resistance to extreme temperatures allows it to be used for transporting water to thousands of homes and industries. It is not a conductor and will not have an electrochemical reaction with acids and bases that it comes into contact with. It is a perfect material for medical applications because it is transparent, flexible, durable, and compatible. Some benefits of PVC to the society is that 57% of PVC's mass is chlorine, so it requires less petroleum than many other polymers. The low cost, excellent resistance, durability, and processability is the reason why dozens of industries today, for example healthcare, IT, transportation, and construction use it. That is why it's the world's third most widely produced synthetic plastic polymer. Some hazards of PVC is that studies have shown that UV radiation from sunlight not only discolors the pipe, but also reduces its impact strength. Dioxin is one of the most deadliest of man-made poisons and is a cumulative toxin, meaning it stays in the body for a long time, concentrating in food chains at the highest levels in carnivores, which include us. Some positive impacts of PVC on the environment is that there are many misconceptions related to plasticizers. For example, about phthalates leaching out and easily dispersing from PVC products. Plasticizers do not migrate or leach into the environment from items because they are physically bound with the PVC matrix. If they could readily migrate, flexible PVC would not remain flexible and perform as intended. Some negative impacts of PVC on the environment is that polyvinyl chloride, the main ingredient of PVC pipe, is classified as a non-human carcinogen. During incineration, a common form of disposal, hydrochloric acid is released, which is corrosive and can cause respiratory damage. It is also not biodegradable or degradable. The breakdown that occurs is just granulation. Animals can ingest these pieces, and the plastic can block their digestive tracts. Studies of animals show that some of these chemicals may cause cancer, kidney, and reproductive system damage. Currently, under 1% of PVC is actually recycled.